We closed out our session on Monday talking about topology, and topology is a fancy word that means map or layout or architecture. Network topology is another way to say network architecture, how it's configured physically with the cables and how the devices are interconnected. Remember that the bus topology we mentioned first, this one is the most vulnerable, but it's also the earliest. You see 10 base 2 here, and that usually means each, so I'm guessing that means 10 megabits, and there are 2 connections for each host, one that comes inbound and one that goes outbound, right? And it is bidirectional, but the thing is, that's the oldest flavor of topology. Star topologies and token ring came along not long after that, and token ring was an enhancement to the original hub topology that formed a star. And then after token ring took off with IBM, it became a quasi-industry standard. A lot of people adopted it for a short time, but then IBM got greedy and charged lots and lots of money for their proprietary network. The switch provided an innovation to refresh the capacity and resilience of the star topology, and that became the de facto standard in many locations. Mesh became, although it was possible before wireless, mesh became a lot more commonplace, especially when wireless and Wi-Fi manufacturers developed features that allowed Wi-Fi routers to interconnect by wireless and then extend another wireless signal out to clients. So it would create interconnections between hosts, and can also experience a mesh network when you configure your Ethernet or your device to engage in a network called peer-to-peer. You may have heard the term P2P networking, but in a wireless environment, it means that there's no real hub. So you don't have a Wi-Fi router. It's just that you have Wi-Fi enabled devices, and they're each connected to each other every which way. So in that context, we would refer to that specific kind of mesh as a P2P or peer-to-peer network. We'll talk more about that in a bit. Remember that when you see WLAN, that's a reference to a local area network that's formed with wireless. And the maximum distance between any 2 points of a network connection is roughly 300 feet. So the maximum distance that you can have with 2 opposing hosts on a token ring or a hub would be actually 600 feet. 300 feet from the host to the switch, 300 feet from the switch to the next host. That's 300 plus 300. Does everybody understand?
Yeah.
Okay, and then if you connect one switch to another, you kind of reset that all, so that if you connect a switch to a switch 300 feet away, then you can extend further with other hosts. So that's pretty much what happens. Now, there is a finite limit geographically and physically to how far you can go, but that local network is often called the broadcast domain, because that's the area physically within which you can carry ones and zeros on the network. Now, repeaters, when we first started, we were talking about how the bus topology was the first architecture for wiring. So we're talking about the wiring and cables. When we talk about the network equipment, the first distance extenders for network media were called repeaters, and they only repeated incoming ones and zeros and then bounced them out another port. So they were outgoing ones and zeros that would go another 300 feet. And these are functionally related to hubs. So hubs are when you take a repeater and you just do that with many ports instead of one device. So think of a hub as a multi-port repeater. Anything that enters any of the ports in a hub is repeated and amplified, and that data travels on the first layer to all locations on that local area network. Now that can be very bad depending on whether you want some data accessible to anyone on the network. Bridges are actually better. So bridges are a device that works on layer 2 on the data link, and they do not repeat noise or collision or bad frames. However, they do repeat multicast and broadcast traffic. They learn computer locations from the source address, and they'll filter or drop traffic based on the destination address if the address shows the host is local, right? So, and actually what I think I want to do is say, if the local address is not local, so it'll filter or drop the traffic based on the destination address. And if the address shows the host is local, it will not drop the traffic. I'm going to revise this page 13. And right now we're on module 2 study guide revision 1. And at the end of this session, I'm going to make it revision 1A, and we're going to correct this right here. Okay. In fact, I'm going to do that right now on the original. Just so we're sure we nail this here, because I don't want to forget it. So I'm going to save as 1A. Does everybody see what I'm doing here? Everybody?
Yeah.
Okay. So if the address shows the host is local, it'll retain traffic based on the destination. If the switch is local, if the host is local, but drop or filter traffic if the host is not local for the broadcast domain. Any questions? So a switch could be considered a multi-port bridge. So if you think about a repeater, and a multi-port repeater is a hub, a bridge is more intelligent and it drops traffic, and a multi-port bridge would drop any traffic that is not for that local host, a given local host. Switches improved on bridges and hubs. A switch dedicates connection traffic for each client. So there's dedicated connection traffic. That means there's more bandwidth, devoted bandwidth for each port. You're not sharing the bandwidth with every connected device. Each device is isolated on its own separate port, and this solves a lot of security and bandwidth concerns. But it was discovered that putting several switches together can cause serious trouble without careful design. High bandwidth interconnections, often called a backplane or fabric, right? Something else was needed to help large local traffic flow better. And that is when layer 3 capabilities became an interest in switches. So they took some criteria, some attributes for layer 3, the IP layer, and they embedded some features into the layer 2 functionality on the switch so that they could extend beyond the natural limitations, right? So there's only so far a backplane or a fabric can interconnect switches. Now, a service router So when we say layer 3 capabilities, we're saying there's a little bit of routing that's possible. We'll talk more about that in a minute. A service router, or the service router provided by an internet service provider, is used to provide the demarcation, that's a fancy name for gateway, the point where the local traffic ends and the public open traffic begins. Now, because the router is a gateway through which the traffic flows, it has an outside address and an inside address. The gateway has two interfaces, and this is not very intuitive for most people. But when you have a single point of demarcation on the outside of that gateway, you have to represent that interface with a public address. On the inside of that demarcation or gateway, you have to have a dedicated address on the inside, right? But because local traffic goes out to other networks or the internet, that's why it is often called a gateway. So gateway, router, network demarcation. Demarcation isn't used very often, although internet service providers usually connect their physical device and they label it and say, this is the demarcation, meaning you don't touch my stuff, yours. After the handoff, so there's a handoff from ISP equipment and cable, and that handoff is the actual demarcation where their stuff ends and the local stuff begins. It's the handoff between public network and private network. We'll get a chance to review that in a little bit more detail. One of the things that I wanted to share with you is that in the last 20 years, though, they've embedded a lot of these network devices and functionality into an all-in-one device we now affectionately know as a Wi-Fi router. So when you have a Wi-Fi router, you have a switch with a local area network, you have a WAN port out to the internet. You'll notice here, there's an outside part and an inside part, right? So we talk about the outside interface with the public network address, the inside interface with the internal network gateway address. We often call the exit side of things the egress, and we call the inside of it the ingress. So one thing that can be a little confusing is that inbound traffic is also, it's called ingress traffic. It's hitting the external interface first. So inbound traffic is ingress traffic. It's inbound, and it hits the external interface first and then passes through to the handoff to the inside, right? Egress is when it's going from the inside out. Egress traffic hits the inside interface first and then ends up outside. The destination is outside. And so this can sometimes be a little confusing unless you walk through it like that. I want you to repeat a review of this particular part of our recording today so that you understand. Now, where's the hub in this? Wi-Fi is basically like a hub. Anything that's connected to the Wi-Fi radio signal, everything that's connected to the Wi-Fi radio signal. Did I mention everything that is connected to the Wi-Fi radio signal gets a copy of anything that is sent or received from any other device in the Wi-Fi? Let that sink in and ruminate for a minute. Okay, so you have a repeater, you have a switch, you have a router in the Wi-Fi router device, often called an all-in-one device. Or now, if it doesn't have a router, you have some wireless access points that do not have a router function or a port to the wide area network, or what we refer to as the internet. So this is something that is really pretty important. A lot of Wi-Fi routers also include a firewall. And what we're going to do is pick up our class on Friday with firewalls. We're going to talk more about how a firewall works, what it does specifically, and why it's such an essential network security device. Okay. So there you have it, the basics of network equipment, essential network equipment, and that's what we'll call this segment when we post the recording online. Can anyone think of any interesting questions or comments to share given the material that was just presented? Okay.